one dimension. One dimension. So we've been talking about why the one dimension is so important. Is equivalent to in your learning algebra. In algebra, a lot of times you have n equation, n unknown, n linear equation, n unknown. So in that cases, you can solve from n unknown equation. So you boil down to n minus 1, n minus 2, n minus 3, and then cut down the number unknown equation, cut down unknown number variables, and boil down to one equation, one unknown. So then after you get one equation, one unknown, then you solve the problem. Two equation, two unknown, three equation, three unknown. The same thing with this chapter 2 about the motion in one dimension. So you got to know how to solve one dimension first before you go ahead to learn two dimension. And the chapter 3 is going to be going to two dimension, and basically equivalent to that is a three dimension. So for all this, we have been talking about section 2.1. We're talking about average velocity. Average velocity. Basically, we say what is, so we start out with speed first. Speed is called time rate of change, either called location or position. And then we got to find out how we're going to take and measure location and position. As far as location goes, we have a measurement. Suppose that there's a location A and location B. The distance between this location A and location B classified as L, or sometimes we call distance. And then this is a distance or length. So in these cases, we like to be aware of it. The length measurement is in terms of centimeters, meters, kilometers, mile, inches, or feet. So what is the speed? Speed is time rate change of location, position. Then it's a delta D, delta T. Supposedly is if you measure the coordinate system, if this coordinate system is around x direction and that vertical direction around y direction, then this delta D, delta T should be changed to delta x, delta T. In these cases, we like to say at the B location is x2, this location is x1. So then we have another written form is called x2 minus x1 and t2 minus t1. So this is speed. Now, the next thing is we like to say what is the, due to the fact we only take into account distance and then the time domain, so that we like to say this is an average speed. The velocity, again, scalar. Okay, the velocity is time rate change of position with direction. So that is with direction. So usually we like to be associated V, and then we go to delta R, delta T. For this particular cases, it's only along x direction, so that we can say V along the x direction is equal to delta x delta t along the x direction, in which cases we like to use unit vector called I. Okay, so for three-dimensional velocity, you can express by vector. Three dimension, we can express by vector. So in that cases, v is a vector, arbitrary direction. In that cases, equal to v sub x, I component plus v sub y, and then j component, and then plus v sub z plus k component. So this is a velocity expressed in the vector dimension, I, j, k. So in these cases, right now, we are talking about only on the x direction. So if you understand how x works, then you understand how y works, how z works. So only. If that is the case, then v on the x direction is equal to delta x delta t. Then if you're using derivative, in which case the calculus is famous on, is called dx dt. Now we like to getting more meaningful information from this dx dt. Okay. Now from the dx dt derivative information, we could express v sub x equal to dx dt. Okay, now we solve this differential equation or simple derivative equation. So you have vx dt equal to x, or you like to say dx is equal to vx dt. And then, ladies and gentlemen, you can integrate. Now, if you say t is a starting t, so you draw a diagram. At this location, t is 0. T equals 0. And in this position, t is equal to t along the x direction. So initially, we like to say at this location is xi, and 0 to t, so we get first equation, x equal to x sub f equal to x sub I plus v sub xt. So this is first equations. Ladies and gentlemen, before we learn algebra or trace or math, we say, oh, this is just a linear equation. Well, we don't know what that means. Okay, we like to solve this puzzle. We like to identify what this is. So this equation equal to x sub f equal to x sub I plus v sub xt. So this is x sub f equal to x sub I plus v sub xt. So look at this. We like to ask how to plotting this. So assume the velocity is constant. So we have vertical cases is called x. This is t. So in that cases, we like to draw, this is initial speed, location, this is x sub f. Then very nicely, we draw a line. So this is a straight line. In our math is usually, if we want to express a math equation, so what is v sub x? V sub x is related with, on the graph, related with the slope of the line. Related with the slope of the line. So this give you the very important idea. So suppose we have another situation. We look at it. Now we know it more now. Suppose we're driving on the speed on the freeway, drive a car on the freeway. Then the position keep on changing, the time keep on changing. We may not have a constant speed. So we on the freeway. This you push the time. This is called x. X of f here, x of I is here. So we might getting some curve like this. So now you got stuck. So I only learned about what we learned before, talking about speed. Is delta x, delta t. How can we handle that? Now remember, this is slope of the line. So even though you have this irregular line, because of the definition, then you say, okay, if I can find the slope here, we are define the velocity or speed. If I have find the velocity, what we call the slope here, then we get velocity. If a slope in here, I can get the velocity. So from the curve point of view, extension on it, if you understand it, that means slope on the x, slope on the x versus t curve, the slope is definitely related to the speed or velocity of the from the other point of view, then you jump start to the real line. Real line means any motion can draw a curve. Any you would like to talk about is called association. Now the question to ask now is very obvious. Why do you have this variation? The variation because you are not driving a constant speed. In this, you're driving constant speed. So what causes the uneven speed? That means the speed is not constant. So if the speed is not constant, what is causing this? Called acceleration. Acceleration. Yeah. Thank you. So we have another term is called acceleration. Due to my poor English, so sometimes you have to make my verbal communication